So this is part 2 for the chain rule, and I wanted to talk a little bit more about how we choose U. And in this case, the U part is usually what we have been referring to as the interior, but we have an exponential function like this. There's really the interior. What do you mean by that, right? So in this case, the way I usually interpret it is that it is the part of the function where if you had numbers, that's where you started to plug them in first. So the interior part would be around the x, so it's starting with the 3x squared. Now, the next question that people usually ask me is, how do you know what u is supposed to be? Well, there's a little bit of a guideline. So suppose that I just wrote it as 3x squared. Then I would have that h of u is equal to e and then raised to the u minus 5. And, well, that is a fine substitution, but we are going to try to find h prime of x as being the derivative of h with respect to u first, and then times the derivative of u. Well, derivative of u is fine, but now the derivative of h is a problem again. So this is not the best way to actually split them apart. What I would say is you take the minus 5, you put that in here, so that we actually have that u is that entire piece that you're plugging into the exponential function. So it's the entire 3x squared minus 5 part. And then h of u is the exponential function. Because at the end of the day, what you want to do is you want to create two derivatives here, your h prime of u and your u prime, that are both easy to compute. And as we have them now, that's about as easy as they get. And so if we take the derivative of u, we get e raised to the u again, because it's one of our elementary functions. And then the derivative of u is the 3x squared. The 2 comes down, so this is going to be 2 times 3x. And then the derivative of minus 5 is 0. And we want to then get rid of the u. So this is e raised to the 3x squared minus 5. And then it's times 6x. And that's your derivative. Now, the fractional notation, so I had mentioned in a previous one before the break actually, that the notation of f of x is kind of the British notation, and the Germans under Leibniz had this notation where they have dy dx, and or it could be df dx. And the way that you think of the chain rule is that there's an intermediate, so you're chaining it through another function. So we would have that df dx, so the change of f with respect to x is equal to the change of f with respect to g times the change of g with respect to x. So, for instance, suppose a gizmo is made of an intermediate product. So you're kind of making something, maybe it's a computer, and it is made out of an intermediate product. So maybe it's completely based on like a piece of technology. Well, that intermediate product, that piece of technology, could be expressed in terms of raw materials. So if you're looking at a computer, it could be kind of made up out of pieces that look like a motherboard, but the motherboard is just made up out of iron and wire. And so you're kind of looking at it that way. So suppose that the gizmo is kind of computed as 12 times the intermediate item, and the intermediate is 7.3 times the raw item plus 0.2 times raw squared. So this is a case where we have something where we know gizmo in terms of an intermediate item and intermediate in terms of raw. What if we wanted to know how the production of the gizmos changed if you tweaked the amount of raw material? So if you kind of change raw, maybe you increase it by just a little bit, then that would give you a different intermediate, and the different intermediate would lead to a change in gizmos. So we want to say, what is the range of change of gizmos with respect to the raw materials? Now, that means that the change in gizmos with respect to the raw materials would be d gizmo d raw. So you would use the chain rule, and you would say, well, d gizmo d raw is you take the change in gizmos with respect to the intermediate item, and then you multiply it by the intermediate item's change with respect to the raw materials. And from the equations that I mentioned previously, if you take the derivative of gizmo, then that's 12 times the derivative of intermediate, that's just 12. And if you look at this equation, what is the derivative of that? Well, it's just 7.3 times 1. And then the raw squared becomes 2 times 0.2, so that's 0.4 raw. So that's how we get 12 times 7.3 plus 0.4 times the amount of raw material. And so that would then end up being 87.6 plus 4.8 times the amount of raw material. So this is an equation that tells you how the production of your gizmos changes when you change the amount of raw material a little bit. And you will see kind of settings like this in the homework.